Howdy, everyone. Today, I want to introduce Jamie Boone as our speaker for this month. Jamie is the Director of Technology and Innovation Policy at Toyota Motor North America. Her core areas of policy expertise include autonomous and connected vehicles, privacy, advanced air mobility, and transportation. Jamie is an experienced legislative and policy professional, having previously served as a longtime aide for Congressman Bill Schuster, last acting as his Deputy Chief of Staff. I'll now pass it over to Jamie for a presentation on autonomous vehicle technology and policy.
Great. Thank you so much, Carlos. And thank you for having me. It's a pleasure. I will just get my presentation up here. There we go. Great. So what I thought I would do today was really give you a solid overview on automated and autonomous vehicle technology. This is an area that is so exciting. There's so much that is changing in this technology, in this field, and so much potential for these vehicles. And for me, this is a big area of policy development over the probably the last five or 6 years. There's been such a focus in this space from the federal government, from the state government, from cities and localities. So it's a great time to talk about it. So what I thought I would do is give you an overview to start of what the technology is and some of the key terms and things that we use when we're talking about AVs, where we are in developing the technology, in testing and in deployment. I'll talk a little bit about Toyota's vision for AVs and what that looks like. And then finally, I'll go through the policy implications and what the opportunities and the challenges are that we're seeing for AVs. So first of all, most important question is, what are autonomous vehicles? You will hear so many different terms tossed around when we're talking about this technology. Automated vehicles, highly automated vehicles, autonomous vehicles, self-driving vehicles, robo-taxis, you name it, someone has come up with a different term for it. And they can all mean the same thing, they can all mean different things. And this is an area where we're seeing quite a bit of confusion, especially for consumers. And in Toyota's vision, it's really important that we provide clarity to people on exactly what this technology is, what it means, and what the capabilities are. So at Toyota, we use two terms. We use automated vehicle technology and autonomous vehicle. So automated vehicle technology is any technology that is partially in charge of driving the vehicle with human oversight. So that is a low level of different driver assistance technologies. Autonomous vehicles is really reserved for those vehicles that are fully capable of driving themselves at a point in time without the need for human supervision. So that's when you're thinking, hands off the wheel, eyes off the road, can take you and can operate wherever. That's what we reserve the term autonomous for. Different companies use different terms. At the end of the day, the most important thing is just to know whatever vehicle consumers are looking at or thinking about, to really think about what the technology is actually doing. So there are levels of automation. So the Society of Automotive Engineers several years ago came up with the 5 levels of automation to help try and provide some more clarity around what these technologies are and what constitutes driver assistance technology, what's partial automation, and then what is actually the highest levels of automation. So they go from, and I won't really count 0, 0 is none. So they really go from SAE level 1 to level 5. And level 1 is just your simple driver assistance features. So it's not self-driving. It is something like adaptive cruise control. Level 2 is partial automation. So that's when you're adding 2 or more elements together that operate the vehicle. So things like acceleration and steering, but the driver still has to be engaged in the driving task and monitoring the environment at all times. So you cannot take your hands off the wheel or your eyes off the road. Level 3 is really when we start to get into those higher levels of automation where at some you can, maybe, take your hands off the wheel for a couple of seconds. And this is kind of conditional automation. And some companies and some people feel like this is just as, if not more difficult than the full level, level 5 total 100% autonomous driving, mostly because it really depends on the interplay between the human and the vehicle, and how quickly, that control, the driver has to be ready at all times to take over for the vehicle. So there's some challenging technology, societal, and legal questions around that, but certainly not insurmountable, but it does make it a challenge. Level 4 and level 5 are really the high levels of automation, what we would call autonomous vehicles, or some would call self-driving. Level 4 means that the vehicle is capable of operating itself within a restricted environment. So certain conditions, or like highway driving, or within a certain geofenced area. And level 5 is that 100% never need to, to control the vehicle, autonomous vehicle. And these definitions are all available at the SAE website, the Department of Transportation, and rely on them. The industry relies on them. So this is definitely your guide for describing what the technology is and what the vehicles can do. Currently, there are the highest level in the United States of automation that we've seen on the road is level 2, which is the kind of partial automation. Japan, there is one level 3 that is in production. Everything else that you see, whether it's one of our vehicles or a Waymo vehicle, is a test vehicle, which could be level 4 test vehicles. So important to know, you cannot buy a self-driving or autonomous vehicle today. So let's talk a little bit about basics of what makes up automated technology. And really, there's kind of three core things that the vehicle does and needs to do to be automated or highly automated. And these 3 elements are perception, which is what the vehicle sees. And this is where your tools like LiDAR, radar, and cameras all come in. So they pull in all of those different factors to see what the situation is around the vehicle and feed all that data into the car. The next is prediction. So that's when you get to an intersection and there's another car. The vehicle has to take all that information that the cameras and the LiDAR and everything has sent, and know what's going to happen next and how to respond to that. And that response then is the planning piece, which is really, I'm at this intersection, there's a vehicle there, the light is green, but it looks like that vehicle's maybe going to run the red light, and the vehicle has to be ready to respond to that and plan what its next move is. So those 3 things really come together to determine how the vehicle is going to respond and to act. And the prediction piece is really the most challenging piece from a technological standpoint, because humans have this uncanny ability to be able to see and read social cues and predict what another human is doing. We're driving down the road, and we're in a city, and you see someone standing on the corner at a crosswalk, and they don't have the light, they're not supposed to go, but you can kind of tell they're about to step out in front of you, and you see that and you stop. That's much harder for a machine to be able to see that situation and to do that. So really building that human knowledge into the technology is a significant challenge, and is what I would say is really taking a lot of time in getting to those higher levels of automation. So what does the road to AVs look like? So we've been at this for a while. Really, since the DARPA challenge in 2004 and 2007, when all these brilliant minds came together to first really start putting together these vehicles to start to drive themselves. through the explosion of investment and new companies that we have seen come into this space over the last 10 plus years, and all of the partnerships that we're seeing between different companies. We're making progress, and but it's not as easy as some would like or would like to think, or I think even a lot in the industry thought 5 years ago. We saw predictions a couple years ago that there would be fully self-driving vehicles on the road by 2019. It was 2020, and then it was 2021. And you'll notice, I think a lot of companies have stopped making those promises because they're realizing how hard that kind of last piece is to get those vehicles to the point where they really are fully autonomous. So for us, it really is, it's about starting with those driver assistance features that really increase the safety of the vehicle, and then building on that and building on that, and then getting to that high level of automation. And whether that comes first in perhaps trucking and heavy vehicles, or in mobility as a service, so things like autonomous shuttles, or in ride-sharing applications like an Uber or a Lyft. There are a lot of different ways that it could go, but it definitely is a long path. So I would not expect to see fully automated vehicles on the road in quite a while. So let's talk a little bit about what Toyota's automated vehicle vision is. So we have what's called the Toyota Research Institute, which was founded 5 years ago to really focus on machine learning and autonomous driving. And through that investment and that project, Toyota has kind of two plans, I would say, that coincide and work together. And that is the Toyota Guardian system, which is really that active safety system that is all about amplifying and enhancing the driver's capabilities to make the vehicle safer for them, to help step in when the human is not able to respond perhaps as quickly as they should be, and to make it safer every day on the road for them. And then the longer term chauffeur model, which is really that SAE level 4, level 5 fully autonomous vehicle that really can just provide such increased mobility for people, and provide those the mobility as a service, to provide greater access for seniors and for people with disabilities to be able to have more options to get around, to get where they want to go when they want to go there. So that mobility for all is incredibly important to Toyota, and just underlies everything that we do, and that we're working in this space to help provide that and help humans get where they want to go, when they want to go safely, when they want to do it. So mobility as a service is an area that's been really exciting, and you're probably seeing a bit of this in Texas. There's a lot of testing going on right now in California and other states as well, from different companies. And this on the screen here is a mock-up of our ePallet, which is an autonomous kind of shuttle service that companies would be able to add their automated system or driver onto. And the vision there really is that it's modular. You can use it for what you need it for. You can use it to move people around. You can use it, you could turn it into a moving retail space, or a mobile office. It's really whatever you need it to be, it can be. So I think that's something that's really, really exciting and really cool. So where are we today? I mentioned that the vehicles on the road today that you can actually buy, level 2 is the highest level, but there is a lot of testing going on all around the country by different companies in this space that are testing level 4 and level 5 vehicles. And the Department of Transportation last year put up the AV test website through NHTSA. And definitely encourage you to check it out. It's an interactive site. This is just kind of a screen grab showing where in the country a lot of the testing is going on. But if you actually go to the site, you can click on these red dots and see what company is testing there, what they're testing, who they're working with. There's a lot of detail there, which I just think is really interesting. And so, like I mentioned, there's a lot going on in California. There's a lot going on in Texas, which we'll talk about in a minute. Arizona is another really big state for testing of AVs. They've had a very friendly governor and legislature, so the regulations have been very welcoming. Same thing with Florida and Michigan. A lot going on there, and of course Pittsburgh. Based around Carnegie Mellon and a lot of the companies that are based there. So Texas has so much going on. It's really has been a very welcoming state to this development. Since 2017, the state has allowed testing and deployment without a driver in the vehicle, which really opens up the state to have this influx of investment from different companies. Obviously, it has been a wonderful home for Toyota, but a couple of really cool projects that have recently come online. I have up there in the left-hand corner, you'll see this RAPID project, which is a demonstration project of autonomous driving, an autonomous shuttle service in Arlington, Texas, that is partnered with May Mobility, VIA, and the University of Texas. And then there's so much going on in the trucking space in particular. Waymo, TuSimple, Kodiak, Aurora, a ton of companies that have been testing the heavy-duty autonomous driving in Texas. And you also have in Fort Worth the Alliance Texas Mobility Innovation Zone, which is really exciting. And there's just been so much encouragement of this activity there, and I expect it will only grow. So let's shift and talk a little bit about the public policy implications. So vehicles, obviously very highly regulated, the most highly regulated product, and with good reason, right? Because safety and lives are at stake. So the primary regulator for vehicles is the Department of Transportation and NHTSA, the National Highway Traffic Safety Administration. And the same goes for automated vehicles. Everything falls under DOT and NHTSA. So a couple of things that have been specific to automated vehicles in the policy space over the past couple of years have been voluntary safety self-assessments, so VSSAs. So DOT several years ago now, under Secretary Chow, created these as a way for companies to be transparent on what their safety case is for their technology and how they're testing and what their plans are really for guaranteeing safety for these vehicles. So they're all they're public. They're on the website. Toyota's is up there along with at least a dozen other companies that have submitted theirs as well. The other thing NHTSA can do is they can issue guidance and interpretations of the rules for automated vehicles. And this is important because the federal motor vehicle safety standards have been written over the past 40 years. When they were written and enacted, obviously automated vehicles wasn't really a thing, and no one really predicted them. So what the challenge now with coming up with these new technologies is how do they fit within the regulatory landscape? And what does FMVSS 108 mean? And how does that fit within the context of AVs? So companies can appeal to NHTSA for some guidance or interpretations on those different safety standards to see how they can comply with them with these new types of designs. And the same thing, also similar, is exemptions. And that really comes into play whenever you have a new vehicle design that doesn't fit within the existing safety standards. So say you want to put a vehicle on the road that doesn't have a steering wheel because it doesn't need it, because it's going to be, a delivery vehicle that is totally automated. That would require an exemption from NHTSA. So there's a limited number of exemptions that DOT and NHTSA can put out, 2,500 a year per manufacturer. So that's something that has the industry has been asking for Congress to increase those numbers so that we're able to put more of those vehicles on the road. Because one of the challenges really with updating safety standards is the amount of time that it takes to do so. It's a long regulatory process. I think the average is somewhere around 10 years. And with the speed at which technology is changing, and is getting better and has the potential to increase safety, that's just too long to wait. So exemptions really are a way to help gather all of the data that DOT needs to update those safety standards and provide that increased level of safety now, rather than having to wait for 10 or 12 years. And finally, NHTSA has recall authority. So if there's a safety defect with vehicles, NHTSA can issue a recall. And then on the legislative side, Congress has considered different types of legislation for the past several years around automated vehicles, starting years ago with pilot projects and research projects, and really over the past 4 years taking kind of a more comprehensive look at what the public policy needs to be around these vehicles. AV Start and the Self-Drive Act were two bills that have come up in the last 2 Congresses, dealing with things like the exemption issue and how DOT should update the safety standards. It's gotten a bit bogged down in the process, where those bills have not passed. They've not been reintroduced in this new Congress. But I do, expect Congress to continue to pay attention to this technology and look for ways to engage to encourage this technology to continue to be developed here, to increase safety, and to make sure that the U.S. remains really the leader in developing this technology and driving it forward. And then finally, the states. The states have a role in licensing of drivers, in setting the rules of the road, and have been really involved on the testing side as well. So we can talk a little bit more about what the divide is between the state and federal responsibilities for the regulation of vehicles, because it's really important for everyone to know what their roles and responsibilities are. They're the same for regular vehicles as they are for automated and autonomous vehicles, where the federal government, primarily through DOT and NHTSA, there are a couple of other agencies under DOT that weigh in on certain specific issues, like the Federal Highways Administration and FMCSA on the trucking side. Primarily, the motor vehicles are governed by the Federal Motor Vehicle Safety Standards, which we talked about. And this is things like manufacturing requirements. So anything having to do with vehicle design, where a foot pedal needs to be pressed, and how, what angles things need to be at, equipment requirements, and performance requirements for the vehicle. And then where the state government comes into play, whether that's through the State Department of Transportation, the DMV, or Public Utility Commission in California. This is where the regulations come in more around the driver. So driver's licensing, insurance requirements, and then the traffic laws that the vehicle operator have to follow, liability questions about liability, and then where it gets a little more complicated with automated vehicles is the states have the ability to require certain types of equipment where there is no federal standard. And we're starting to see that crop up a little bit in certain states where, you know, they require, you know, windshield wipers or something. And, you know, when we get to a point of AVs with different designs, they might not necessarily need those. So that's starting to be an issue that is requiring a little more conversation at the state level. The states have been really active in rules around testing and deployment. Now, I mentioned that the federal government has responsibility for the manufacturing requirements for a vehicle. That hasn't necessarily stopped all states from you know, attempting to add their own you know, requirements for, you know, how a vehicle needs to act if it gets in a situation that it can no longer safely operate, or, you know, different notification lights or alarms or things like that. But we're definitely in a different place than we have been in the past couple of years. I think states are really starting to get a better grasp on what this technology is, and working more closely with industry to figure out where the gaps are, and where they can be most helpful in engaging in this technology. So I have here just two maps showing states that have passed legislation and have laws surrounding the testing of automated vehicles. And then on the right, states where they have specifically authorized the deployment of automated vehicles. Now, it's important to note that a state doesn't proactively have to allow automated vehicles on the road. With the exception of New York State, which I'll get to in a minute, AVs are, for the most part, are legal today on the roads. Most states, you know, don't need to pass anything to change that. New York State is an exception to that rule, because they have a rule requiring a driver to always have one hand on the steering wheel. So when it's an automated vehicle, that obviously doesn't work. So that's the exception there. But a lot of states have passed both testing and deployment laws. Where you start to see some trouble is where states that have, you know, authorized testing programs, but then haven't said anything on deployment, and don't necessarily have a path to deployment, or don't allow deployment. So let's shift a little bit to infrastructure, because it's finally it's infrastructure year, everyone's favorite topic. And when it comes to AVs, there are a lot of nice to haves and considerations. There really aren't any specific, you know, needs for AVs to be able to operate. We don't need different roads or different road design for automated vehicles. The whole point of AVs is that, you know, they should be able to operate. They should be able to perceive and respond to the situation and operate safely at all times, and on the existing infrastructure. Now, there are things that can be helpful. Currently, USDOT is working to update their manual on uniform traffic control devices. So, you know, that manual, I'm sure you all are very familiar with that, so I don't need to tell you what that is. But you know, when it comes to AVs, there's nothing specifically, you know, that we have to ask for autonomous vehicles to be incorporated. Really, things that are helpful for all vehicles are helpful for AVs as well. Clear and well-maintained road markings are helpful, and really, you know, that comes from the perception standpoint. You know, that just makes it easier and safer. And then uniformity of traffic laws. You know, different states tend to have, you know, slightly different rules around their traffic laws. So, you know, how far you have to stop from a stop sign or a school bus. That gets really, that can be really difficult to engineer for when you have 50 different states with 50 different laws on, you know, each little thing. That can be a significant engineering challenge. So as far as, you know, states are able to work with each other to harmonize, especially, you know, neighboring states are able to work together to harmonize those rules, that's only helpful. And then long term, there's a lot of considerations to think about. You know, and I'm talking, you know, anywhere from 20 to 50 years down the road when maybe most vehicles are automated, and the way that we move about, especially in cities, is different. So looking at things like curb areas, how wide streets need to be designated, drop off and pick up areas. Do we need parking structures, the same way and in the same place as we used to? Those are all long-term things that you'll see a lot of really interesting ideas around and reports around. But I'd say it's a long ways away, that we need to think about some of those questions on such a massive scale. And then the other is where do connected technologies fit in with this? You'll notice we talked all about autonomous vehicles. Connected vehicles is different, especially when you're talking about vehicle to vehicle communication, vehicle to infrastructure communication. That's a different technology. A lot of times those go hand in hand, and connected technologies can definitely enhance and help in automated vehicles perception and decision making. But it's not necessarily required. That's something, there's a lot going on in the V2X space, especially when it comes to the spectrum, which we won't get into today, but I'm sure a lot of you have dealt with a lot of those questions. So overall, this is a really exciting space. There, a lot. It just changes so much every day. The technology changes, partnerships change. New companies come into the space. We see, new applications for things that are maybe started off as something that was being researched for AVs, but then actually could be really helpful in another context. You're seeing that right now a lot with LiDAR, and more broadly with machine learning. And so that those different developments, there are a lot of lessons that can be and will be learned from the development of AVs that can be applied to different spaces, and you're just going to continue to see that. Overall, the things that we've learned from the research from the autonomous side, a lot of that can be taken and applied to lower levels to just enhance safety features on vehicles and help work towards that goal of cutting down on vehicle and roadway deaths. So I'm really excited about the future of AVs. I hope you are too. It's definitely a really interesting area to work, and I'd say I welcome your questions, your outreach, and I'm happy to be a resource to you as much as I can be. So thank you.